Hi everyone, my name is Gabrielle Crevecoeur. I know that there's been a mix-up on the schedule, like the board says something else, the app says another, the site says another. So I think me and Bobby got our talks mixed up. On the board downstairs it says that he's actually in this room and I'm in Pepsi Encore. So if you're here for Bobby, he is actually in Pepsi Encore. So if you leave, I won't feel bad now. If you leave later, I'm going to be like, dang, I'm really that bad. If you're not sure what the topic of today's discussion is, today is how to build your child their very own frozen NodeBot. So this is a hardware talk. I know someone asked me earlier, is this like a virtual bot, a chat bot? Because there's all these bots nowadays, you really don't know what we're discussing. So this is a hardware talk. So a little bit about myself. I am a technical evangelist at Microsoft. I just completed my first year last June. So I'm technically now a veteran and I should know how to do my job. You can follow me on Twitter at NoWaySheCodes, and you can actually follow my blog, NoWaySheCodes.com. Before Microsoft, I was a computer science major from the Florida State University. Go Noles. So if you ever want to discuss college football, we can do this all day, you know. At Florida State University, I focused a lot on web dev, JavaScript, basic HTML. It wasn't standard at my school, but I just went above and beyond to learn all things web dev because I thought it was just pretty cool. All my internships were web dev development. And then once I got to my job, I decided that I wanted to do something different because I was really bored with web dev. It's still interesting to me, but I feel like it wasn't challenging me anymore. So what I went in to do was, okay, you know, I talked to my boss about it. As a technical evangelist, we all kind of have our own different focuses on my team so we can reach out to everybody and kind of hit different fields of people. You know, actually there's no tech TE on my team that actually does .NET, which is pretty funny because everybody thinks .NET and C# with Microsoft, but nobody on my team actually does that. So I kind of wanted a way that was like, you know, what's new, what's happening, what's going on in the world, and I discovered hardware and JavaScript can actually go together, and it kind of blew my mind. So as a CS student, though, we didn't really do anything hardware, and it was really such a great transition to learn about circuits and electronics and things like that. So I wanted to make a talk for others that, you know, were new to it. And even if this isn't new material, even the technologies that I'm using may be new to you. So I do want to know a little bit about my crowd, so I'm just going to throw out little questions, and if it applies to you, you know, just raise your hand. So how many people in here have never done anything hardware before and just feel like this is all new and they're just interested in getting started? Oh, wow, that's okay, that's great. How many of you are kind of like me where it's like, well, I don't think I'm a beginner anymore, but I'm still learning a lot. I'm not like totally 110% on hardware, but I do like it. Oh, great. And how many of you are just like, I'm a beast, like, I do this all day, every day? All right, great. It's always good to know your audience because it's like, I don't want to talk about the basics and there's other people in the room like, girl, I already know this, like, can we move on? So thank you for that. So let's just talk about the story. I mean, once you get into your professional career, you know, a lot of people start families, they have a lot going on, and it's kind of just like, I feel like there's a hard way to figure out, well, now that I have a family or a child of your life, whether it be a daughter, a niece, a goddaughter, something like that, you know, you always want to give them time because kids are cute. If you don't think kids are cute, then I'm sorry. Because kids are cute and, you know, you want to be able to give them everything. So this is the child of my life. She's not my daughter, even though we look just alike. She's actually my 6-year-old sister. So the gap is crazy. I don't know what my parents are doing, but that's on them, not me. But either way, you know, I treat her kind of like a daughter because you're 6, I'm like 23. So everywhere I go with her, it's just like, you know, I want to give you the world. But when I graduated from college and I would go home, and work from home. Let me fix this, sorry guys. I would go home and work from home, you know, we'd actually like kind of fight it's weird fighting with a 6-year-old because she's so smart for 6, and you think she says it's unbelievable. But it's just like, you don't have tea parties with me anymore, and you don't want to do this, like, you don't like me. And I'm just like, no, I have a job. That doesn't really register with her. So it was really actually breaking my heart because she really is my world. And it's just like, okay, well, I need to find a way to make my work time my play time. So in my head, I made my system my customer. Like, what can I make for you that'll make you want to be like, yeah, I love this, but I'm also learning, I'm building, and you're my test subject. I can turn that in for work. That sounds great. So that is the story of how this bot came to be. Before we actually kind of get started into the building of the NodeBot and things like that, I do want to talk about, how do you actually get started in hardware, and how do you figure out what you want and what you want to do? There are about 1 million different types of boards that you want to get started with, and when you look up hardware or microcontrollers and microprocessors, you'll have a vast majority of options. Like, it's just crazy. You don't really know where to start. As a beginner, from my experiences, the first things that normally pop up, or the first 2 things that are like, what board should I start with, or all these projects that people are building with boards, is usually an Arduino and a Raspberry Pi. And they're so popular, but a lot of people don't always know the difference. So the difference to me is an Arduino is actually a microprocessor. So your Arduino is really good at taking maybe 1 or 2 things and doing it very well. It doesn't have its own operating system. You actually give it code via your computer. You can actually Bluetooth code to it. And then it just does that one thing over and over and over and over again for you. It's really great. It does have digital input and output pins, and it works for simple things. Versus when you have a Raspberry Pi, you have a mini computer in your hands at all times. Anything that your computer can do, most likely your Raspberry Pi can do. So when you have a project where it's like, I need to do this, that, and the next, and process some of this, and work with that, you might want a Raspberry Pi. So when you're thinking of, well, what do I need to get done, and you're thinking of your problem, first things first, I would think of your complexity. Think of how complex your issue is and what you actually need from it. It is also kind of weird because a lot of things that an Arduino can do, a Raspberry Pi can do, but then it comes down to the connections and how Raspberry Pi has 1,000,001 different pins. If you have never done electrical engineering and you don't understand pins and pinouts and how this connects to this, I would really suggest an Arduino to start, because their pinouts are actually a bit more simplified versus a Raspberry Pi pinout. Every layer of pin is actually something different, and you're not always gonna know what connects to what. Versus a Raspberry Pi, you can kind of versus an Arduino, you can kind of plug in anything, anywhere, and just state a pin number, and it'll all work the same. Any questions? Okay, yeah, feel free to stop me at any time while I'm talking, if you would like to know anything. So another thing that's really important to know is, okay, now that I have my hardware, how do I want to actually make my board work? What do I want to get started with? So a lot of times these boards will have native languages that they're used to. Arduinos actually are really big with, they call them sketches. They're very similar to C and C++, are like a mixture. So usually if I write an Arduino sketch, I will probably write it in C++, and it normally works just fine. There's very little errors. A Raspberry Pi, like I said, is a computer, so honestly you can really run anything on it in any language that you want. However, a lot of the tutorials, there's actually a terminal on there. Everything that it's natively running is Python. So if you're really good with Python and you love that, a Raspberry Pi is the way to go. So that's really good to know. For me, I love JavaScript, and you're like, well, nothing you said included JavaScript, so how does that make any sense? Well, as I was saying, when I was looking up things for my job, I discovered JavaScript and hardware, and they call them NodeBots. So you're literally running Node.js on your hardware. How this is happening is not me. I'm not that great yet, but one day. This guy, his name is Rick Waldron. He's super cool. He's located in New York. He has actually created a bot framework called Johnny 5. So I'm going to just see if I can pull up the website for you really quick. My computer's a little slow. Okay. So this is literally Johnny 5. As you see, it's called the Robotics and IoT platform. Johnny 5 is actually able to work with a multitude of boards, just like the Raspberry Pi, the Arduino, there's Tessels, there's a million and one things, and it actually has great documentation on how to get started and what you want to get done, and et cetera, et cetera. What it really does is it'll actually do JavaScript to only communicate with its base language. So when you're running JavaScript, you're really just controlling any C# or any C++, sorry, that you might have uploaded already on your Arduino. And I'll actually show you guys how that'll work in a second. So yeah, if you ever just want to know, it's Johnny-5.io. Hold on, you guys, this is not working out. Okay, so Johnny5.io. It's a really great place to get started. Like I said, great documentation, and there are a bunch of people actually, if you find the GitHub repository, there's a bunch of people that are actively building on this and adding to it and things like that. So it's a great community to actually be a part of, and I'm glad it was one of my first ones to be a part of in my job. Okay, back to the slides. So just like everything in the world, when it comes to programming and getting started, there's always that one program that you learn when you first get started, which is Hello World. There is actually a Hello World in the hardware world. Before we get there, though, I do want to skip forward for a second, just so you understand something that I'm actually about to show you. So these are shields. Hardware has a lot of accessories and things you can add to them. So a shield is pretty much an additional piece that you can add to, normally your Arduino usually has shields, but a lot of other boards will have it as well. I don't think I've ever seen a Raspberry Pi shield. I could be wrong, but mostly when you look up shields, they usually go within Arduino. And a shield will fit snugly right on top of your Arduino and actually give it the same pinout so you can still add other pins to your Arduino. But the purpose of shields is because your base hardware, your regular Arduino Uno, cannot do everything that your brain may want it to do. So for example, if you want to play music, if you want to light up a bunch of lights, if you want to actually connect to Wi-Fi, your Arduino board can't do all those things by themselves. So there are a numerous amount of shields out there that may provide different functionalities for the different projects you may want. So it's really cool to just see what they have out there and look into it and things like that. So I mentioned that because I actually have a shield on my board right now, and I didn't want you guys to look at the Arduino and the shield while I'm doing Hello World, and you're just like, well, that doesn't look like an Arduino. I don't want to go into what my shield does yet, but we will get there. So first, let me show you how Hello World works, and you're going to see the C++ aspect of your Arduino sketch, and then how the JavaScript works on top of that. So with Arduino, to upload code, is that big enough for everybody? Okay. To upload code, it's literally, this is your interface. You don't have anything else. You can upload different sketches. You have a sketchbook. There's already built-in examples and things like that. When you're working with the Johnny 5 framework, what they use is standard Fermata. So Fermata is pretty much the protocol that your Arduino uses when it's actually communicating with your computer and things like that. So the communication between the board and letting it know what's going on. So Fermata will be actually something you'll always see when you're using your Arduino. You download Fermata, you get it on your board. It's pretty standard. To do everything else, though, you will not need standard Fermata, but when you're actually running Johnny 5, you will. So it's just very simple. You honestly get Fermata. It comes built in with your Arduino IDE. You literally just go to examples, find Fermata, and then go to standard Fermata, and it will pop up right here. So it's also really important to note, which this will also come into play later, is you always want to know what port your Arduino is coming in. This can always change. As you can see on my MacBook, oops, didn't mean to click it. On my MacBook, it looks like this, like dev cu.usb modem, but on a Windows machine, it actually will say like COM, like COM 1, COM2, COM3. So just in case you have a Windows machine and you're working on this, it's like, well, her port number didn't look like my port number. Is something wrong? No, just different machines. So you want to keep track of that. Right now, 1421 is my base number. That's the only thing that will change. The rest of the port string will stay exactly the same, but your number is what's actually really important. So that's highlighted. I'm going to upload standard Formata onto it. At the bottom, you can see, I know it's really tiny, I can't make that big, I'm sorry, but it says uploading and it lets you know that it's done. So now for the JavaScript part of it, now that I have standard Formata on it, I can do anything that Johnny 5 is capable of doing at this point. So I'm just gonna open up my Johnny 5 file. So hello world. This is literally 9 lines of code that is gonna make my LED blink. And normally with Johnny 5, you're not gonna have a very extensive piece of JavaScript. It's really just gonna be something this small, maybe a little bit bigger when you're running Johnny 5. When you're running the Johnny 5 framework, it's pretty simple. It's pretty straightforward. So as you can see, is anybody not familiar with Node and Node modules? Okay, so if you don't know, Node.js is pretty much running JavaScript outside of the web. It's pretty cool. It's right now my favorite thing to do. And so when you're running it outside of the web, Node has, oh, zoom in more, sorry. Is that better? Great. Node has these things called modules. Coming from an object-oriented background, when I think of what a module is, I can almost compare it to a class, even though a Node module is more of a package. But right up there where it says require Johnny 5, that is a Node module, and it contains a bunch of different functions, different objects, different variables that you can access once you call your Node module into your code. Does that make sense? Is there any other questions on that? Okay, so as you see at the top, we're saying, hey, I just want to bring in the Node module Johnny 5, and you're just giving it a name, so 5. So every time that 5 is included in the code, we're just calling upon the Node module. The next line, you're creating a board object, which is only just grabbing the definition of what a board is from your Johnny 5 module. From then on, you're actually running your function. Okay, well, when your board is on and when my board is ready, can you just run the function that I'm telling it below? Is anybody misunderstanding that, or is there anything weird? Okay. So under that, as you can see, it says, hey, we have another object called an LED, and I want this LED to be instantiated as the LED object that Johnny 5 provides, that definition of LED that Johnny 5 provides. And in between, you see it has this number 13. That number 13 is just the pin on the Arduino that you're going to plug in your LED to. So when you're adding LEDs or you're adding servos or additional parts to your Arduino, they're most likely going to be accessed via a pin. So your pin number is very important. Depending on what kind of board you are using, sometimes your pin is not actually a number. Sometimes it's like A1 or D something. In this case, for your Arduino, it's just pin 13. So really quickly, let's get this LED up and running. Where is, so you guys can actually see what's going on. Oops. Can you guys see me? Yeah. Hi. So this is my Arduino shield on top. The Arduino is right at the bottom. So the shield's at the top, and literally these are the male header pins, which means it's just taking something being plugged into it. That's all. It's a male header pin. That's all it's taking. And this pinout is actually identical to what the pinout is at the bottom on the actual Arduino, so that any pin you plug into the top, the Arduino can still process it. So I'm just going to plug in this LED right here to pin 13 and ground. So all I'm really doing is completing a circuit. Pin 13 is kind of giving is like putting power up into the LED, and then the power is being pushed down into ground, and it's like looping around. So it's completing a circuit. Yeah? So now that the LED is plugged in, let's actually run the code really quick. I know my head is in the way. And then we're just going to say node, hello world. Do y'all see that? Yeah? So as you noticed, we uploaded, oh, go ahead, clap. Yeah. Oh, let me take me off. This is awkward now, Okay. So as you can see, pretty much what we did was we were able to, we uploaded the standard the standard protocol onto our Arduino, but honestly, the JavaScript is what controlled whatever standard Fermata was giving it. Because standard Fermata just is like, hey, your Arduino could do these basic things, and JavaScript was like, well, I'm going to take these basic things and make it happen. Does that make sense to everyone? It's pretty cool for anybody that just wants to stay JavaScript focused because you don't actually have to look at the standard Fermata code at all. You don't have to do C++ if you've never done it before. So if you just want to stay JavaScript focused, it is a great way to do that. So Johnny 5, people, remember that. So now let's actually talk about my FrozenBot, how we built in, and what goes into it. I normally actually have a doll. I think I might have her, actually. Okay, I do have her. So this is Elsa, everybody. Okay. So does anybody not know what Frozen is really quickly? All right, so if you don't have a child in your life, you might not know what Frozen is. Frozen is the greatest movie of all time. Woo! I say this because I really hated it until my little sister was like, no, you have to watch this movie with me. Like, this is happening. Like, this is not a discussion. This is like, no, I'm telling you, like, we're watching this. And it's actually a really good kids got So I pretty much made this bot. It's all an illusion. What I do is I normally take my Elsa doll, and I got it actually from the dollar store. It was actually a container that had snowflakes on it. Because Elsa, snow, she like blows snow around and things like that. She's great, she's really cool. And so I would put Elsa on top, put my Arduino on the bottom, and kind of like stuff some stuffing in there so she doesn't see the board. And then I would actually let the board work. So the way it works is the FrozenBot is voice activated. So once I turn it on, Elsa has to hear Frozen, Elsa, or sing. And when she hears those words, then she will sing snippets of the infamous Elsa song, Let It Go. If you haven't heard Let It Go, you will hear it today. Not the whole song, not the whole song, it'll just be snippets of it. So that's what I built for my sister because honestly, clearly she was obsessed. I think Christmas break one year, we watched it every day. Christmas break is 3 weeks. That is 3 weeks of Frozen. Needless to say, I'm over it now, but I actually ended up falling in love with the movie. I actually have my own stuffed animal of Olaf, if you know who Olaf is. He's my favorite character in the movie, and I begged for my mom, to buy it for me on Blu-ray. I was like, no, I need this movie today. So, so it was for her, but I actually did find enjoyment actually building it myself. So first thing, the hardware that I decided to go with for this project was an Arduino, which you just saw, that shield on top of it. And what that shield is, it's just an MP3 player shield. Because you're wondering, well, where does the music come from? Inside of the shield, there is an SD card. And I simply just put, I think, 5 snippets of the Let It Go song, the highlights of the song that everybody knows. And I put it on there. And once the shield is triggered, it'll play the music. So then on top of that, what makes the shield even more awesome is I didn't have to wire up a microphone. I didn't have to wire up a speaker to it. The shield actually has a mic port and a speaker port. Look at that, it's all done for me. Because if you look up Arduino and a microphone, it'll give you a way to wire one up. That microphone wasn't really that great. But this just made it so much easier. I just plug this in and it does everything I want it to do. Wow, great. So that was honestly what I used. And as I explained to you before, there was standard Fermata library. But with this shield, it actually came with its own library, 1. And 2, at the moment, Johnny 5 wasn't compatible with it. So now I'm sitting here I guess this isn't a NodeBot anymore. We're just going to let this go. Let it go? Get it, guys? I didn't do that on purpose. I didn't do that on purpose, I swear. But So what I actually found is there's actually another JavaScript to board or node module or framework. It's not as popular, but a lot of people do use it for things that Johnny 5 was not compatible for at the time, because it has grown since I built this project. But even still, some people just prefer this method. So it is a node module called serial port, which really just communicates the Arduino via serial port. Oh, look at that, it makes sense, boop. So it was actually pretty simple. So only Arduino library I needed at that point then was just a sketch to make the shield do what I want it to do. And my JavaScript at that point kind of was the brains behind everything and kind of just shot signals and grabbed info from the shield. So my JavaScript actually does all the work. It's okay. Which actually makes me like serial port even more because I feel like I actually see my JavaScript do all the work. And then on top of that, I actually have this little mini speaker. I know it's like bright. I used to have this one that was like a pom-pom, so it blended more. And it was blue, so it sat under the blue container just right. But it just kept blowing on me, and that would have been awkward. So I have this little speaker that's nice and bright. You guys can't miss it. And I'm just going to go over some code with you really quick so you can understand. So like I said, with my JavaScript, doing all the work, being the brains behind everything. So all my JavaScript is doing right here is we have at the top a record module to know that we are actually recording something. By default, right now, I honestly, this particular bot actually just records from my computer because you can't really have an Arduino run by itself unless you give it power somewhere else. You have the Bluetooth added to it so it can so the Bluetooth can actually upload the sketch. It can get kind of complicated. I'm actually rebuilding this board on a more portable board so then I don't have to talk to my computer and it looks better. But to her, she doesn't notice these things because it's like the hardware isn't really going anywhere, you know? She's just gonna take the doll and run around, which is fine. So that is what the top module does. It's really just for recording purposes. The next module is FS, standard file stream. So it's what is going to write my recording into a binary file. And then under that is speech.js. So speech.js is actually a module I made. Making a module is very easy. It's just like making a class. And that's honestly just how you call it, my speech.js file. And that's kind of how the speech is actually interpreted and things like that. And the speech is where I call the API that will tell me if she said the words that I'm looking for. So the API I used is actually Microsoft Cognitive Services. I honestly, not being biased, I did do Microsoft Cognitive Services and I did do Google Voice. And Google Voice kept giving me, oh, I'm 60% sure that instead of saying Elsa, you said Ellie. Or instead of saying Frozen, you said Frost. And I'm just like, this isn't going to work. But Microsoft Cognitive Services is actually very accurate. And I hate to say this, but I was really surprised because you know, I do love my company, but you know, sometimes we're not always on point. But we were on point with this one. So I was like, yeah, great. Don't tell them I said that. So these are just variables that are needed to make that API work. I just have my client ID, my client secret, the file name that'll be used to make my recording into a file, and then this number. So this random number is, you know how I said that I had 5 snippets on the shield? It's because I don't want it to play the same thing over and over. I just want to play something. So it'll pick a random number 1 through 5, and all these variables are going to be passed to the function that actually talks to the shield. Are there any questions so far? Okay, great. So in this function right here, this is just really where the recording starts. Actually, recording stuff, recording and doing anything voice related can be a little complicated in Node because Node runs asynchronously. So it'll be like, hey, record start, but actually go to the bottom now and do something else at the same time. And your other function may be like, well, I didn't get my recording yet. So you actually want to play around a lot with Node to figure out how you can fake the synchronous nature of it. So I did a set timeout function, which makes it like not do anything else until this recording is done. There are other ways around the asynchronous nature of Node. There are actually Node modules like async that makes it run synchronously. I'm not going to go too deep in that, but that is actually very, very important when you're dealing with NodeBots. If you want things to go in order, it won't. It'll all happen at the same time, so you actually want to find a way to make it go in the order that you want. So all this is really saying is start recording. Once it hears something, I give it like maybe 10 seconds. My sister, actually that's 4 seconds up there, but my sister is not going to take longer than 10 seconds to be like, okay, I want this doll to sing. Like, you know, she's pretty smart. She knows what she wants. She's going to get right to it. She wants the freaking doll to sing. So, so I give about a 4-second snippet, and once it takes this snippet, it pipes it down into a WAV file, and it sends the WAV file into the speech fun function. So the speech fun is what actually calls that speech.js module I was talking about, and it runs the API get and post request that I actually created in the speech.js file. So that is all that happens down here. What is this? I think it's gonna make it happen on purpose, and I don't want that. Okay, no, that's fine. Actually, that was a test statement. So down here, this is the analysis function. So once I give it up to the API, Microsoft Cognitive Services will return, there's a speech to text method for me, and it will return everything that she has said, text into like a JSON. And I pretty much go through the text in the JSON, and I look for, does she say Elsa, Frozen, or Sing? And if she does, then where it says port.start, it starts the serial port with a random number. So you just pass in to the serial port, hey, here's my number, play this song. Any questions? Anybody want to see it go?
Yeah. So it's already parsed speech into text for that point?
Yes. Yes. I think.
What's the purpose of the random number?
The purpose of the random number is because, sorry, I have 5 tracks on here, and I don't want it to play the same track every time. And the way that the shield will play a track is you give it a number. You give it 2, you give it 4, you give it whatever, it'll play that track that's located on the SD card. So it's just a random number so that every time the doll is singing the same part, and she's just like, this is boring, because she gets bored really easily. So anybody want to see it work? Yes, all right, so you don't actually see the doll and the aesthetics of it all, but when I put it together, I swear it's really nice. So I just want to make sure that my port number is correct. This is the serial port function I was telling you about, and that port number is actually very important because then it won't know where to communicate. This right here is when we're calling the serial port object. It's pretty much sending in the native variables, I say variables, but the native settings that the Arduino has if I was running the shield via Arduino, the serial port is just passing that to it so it knows how to configure the Arduino. That's all that is. And then right here is that start function that I was discussing. And pretty much this SP write is what will give it the number and make it play. Make sense? Okay. So let's make this bad boy go. Something isn't right about this though, but it should work. So this is super tiny. So Node, oops. Anybody want to come try it? Come on, come on, come on. Do you remember the keywords? Frozen. So yeah, just come up. Oh, you can just stay right there. It's fine. We're going to talk to the computer anyway. So when I say go, you might want to say Elsa a bunch of times, Frozen. You could say a sentence with all 3 words in it, and we'll see what happens. Okay? Ready? Go.
Elsa.
She's in here.
Frozen. Sing. Elsa.
Oh. Oh, this got awkward. I haven't had this before. Clearly, my subscription key just died this morning. This honestly will be a 2-second fix, people.
You'll have to sing yourself now.
Oh no! I think it's because honestly, I tried to like do my environmental variables, and I think that's what's happening. So I'm hoping that that's all that it is. Hopefully, it's nothing else, because it would suck if it is, you know. All right. Let's try it again. You ready?
Yeah.
All right.
Elsa, sing, Frozen.
Elsa.
Elsa,
Okay. No, you know, it's always something, man. You just can't win. Oh, sorry, guys. I did skip a step. I still had standard Fermata on it, and as I told you guys before, it has to have the actual shield one, so I'm just going to quickly re-upload this. Just know everybody makes mistakes, you know what I mean? We're not all perfect. I wish I was perfect, though. So this is just pretty much the same thing. Well, another sketch, but as you can see, they're pretty simple. And just upload. It's uploading down here. Speakers on, everything's on, we're good to go. Great. Now I promise you this time it's so totally gonna work. Okay, come on, you ready? You thank you for being a trooper with me. All right, let's do it.
Elsa,
Elsa.
Frozen.
Frozen.
Sing, Elsa.
Okay. Thinking about it. That's good, that's a good sign. So they're like 10 seconds, so like it just ended because the clapping was about, that much time. Yeah, you can go, thank you so much. Thank you for her. She was awesome, guys. She was a trooper. But pretty much this is it actually talking to the board. It'll have usually it has a lot of more numbers and just letting you know that it's working. But what I actually noticed when I was working with serial port is it would go through an infinite loop and just play over and over and over and over again. I was like, no. So if you look actually right here in the serial port, after it actually runs the function, after it like gives it the number, it closes the serial port very quickly. So that's why it looks like, oh, the data is being cut off. No, the data will keep going, trust me. So that's all that is. So let's get back to the slides. So we actually discussed all of this already. So next steps. If you would like to build your own FrozenBot, you can do that. I have step-by-step instructions. I have a list of all the devices, all of the things you're going to need for your device and things like that at aka.ms/FrozenBot. I'll actually show you the site right after this. It'll have all the same pictures you've seen, so you'll know it's the right one, because these are self-photographed, because, I had to like add my personal touch, so that's my Olaf doll. Isn't he so cute? And then it's like, just because I build this bot doesn't mean you can't take it to the next step. Add things to it. Make your bot spin around and do a little dance or something. I don't know. But also, if your child doesn't like Frozen, you can totally supplement this for a whole different character. I personally like Mulan. She's freaking awesome. So like, if I could easily take snippets from the movie, upload that to the SD card, change up the doll and the aesthetics of it all, and now I have a Mulan bot, So this bot isn't necessarily set in stone, and I hope this session has taught you that, you can kind of take this, play around with it, have some fun with it, and things like that. Definitely look into Johnny 5 if you want to get into NodeBots. If you just want to do hardware in general, there are 1,000,001 tutorials all over the place. And at this point, there are 1,000,000 different platforms to run your board. I use my native platforms, but once again, there is Windows IoT. It's getting there. It's good. It's good for what it can do, but it might be limited in the things that you may want to do. So feel free to explore all the different options you have for each board, because there are 1,000,001 ways to implement things nowadays. So that's the end of my talk. If you have any questions, if you have critiques, if you want to tell me that I suck, you can come and do that. Please let me know that I suck so I can get better. But I hope you guys really enjoyed this time and this talk, and I hope you guys are all able to take away something from this. Thank you.